I'd like to welcome everyone to this week's Wednesday webinar, which I'm very pleased to say is a joint event with the British Astronomical Association and the Society for Popular Astronomy. And we have Alan Lorraine, the President of the BAA, and Robin Scadgel, the Vice President of the SPA. I'll hand over to Alan and Robin to do the introductions. Thank you.
Thanks so much indeed, Andy. Good evening and welcome to tonight's webinar. Thank you, Andy, for introducing us. I'm particularly pleased that tonight we have a joint meeting with our friends from the SPA. Prior to COVID-19, we had scheduled 2 joint meetings on astrophotography. Obviously, they couldn't proceed, so we thought it appropriate that we at least have a joint webinar. So tonight we have the BAA's section director for the Jupiter section, Dr. John Rogers. He'll be talking about the opposition of Jupiter, which happened, I believe it was yesterday, but also as well about the pro-am work that amateurs are able to do on Jupiter in conjunction with the Juno mission as well. So we'll also have, Robin will be talking about the latest developments on Comet Neowise and showing some pictures, I believe, before Greg will be moving on to be talking about myths and illusions. And obviously Greg is well known to many of the Astronomy Now readers as well. So without further ado, Robin, did you want to come in at this stage as well, or should we go straight over to John?
Yeah, I'll just say hi to everybody, and I've been a member of the SPA or JS. It started out since 1963 and the BAA since 1964, so I've got a foot in both camps. And as you say, we have been talking about joint meetings, and this provided the ideal opportunity. It's a very, very rare cloud with a silver lining. So glad to see everybody, and on with the show. So I'll leave it up to you to introduce your speaker.
Excellent, thanks so much indeed, Robin. So without further ado, pass it over to Dr. Over to you, John. Thank you.
Thank you, Alan. I hope that's not the dreaded COVID. Well, good evening, everybody, or good day or good night, wherever you happen to be in the world. Whatever part of the world you are in, yesterday it was opposition of Jupiter. And so in this talk, I'm going to be showing you some of these splendid images that people have been obtaining and describing some of the features that are of interest on Jupiter at the moment that we can see with our telescopes, and also some that Juno has been seeing as well. Jupiter was indeed at opposition. There it was a week ago next to the full moon. There's Jupiter and there's Saturn, which is also going to be at opposition very shortly. It's not the only planet that Jupiter is in conjunction with, because here is a picture of Jupiter with its satellites, and over there is Pluto, which is actually at opposition today. So planets Great and Dwarf are all coming into the sky at the moment, and plenty to see on all of them. And Robin is going to mention that more in his session. But as anyone in England knows, the planets are, at least Jupiter, Saturn and Mars, are currently very low in the sky. They don't rise more than 16 degrees above the horizon. Whereas for people down the southern hemisphere, they're absolutely splendidly overhead. It's still possible to see something from Britain. So this is an image by Pete Edwards that was received a few days ago. It shows a surprising amount of detail for such a low altitude of the planet. Just a few degrees south in Paris, Jean-Luc Deverne obtained this superb image for the conditions, where you see Io and its shadow there transiting across the planet. But if you do go down to the tropics or to Australia or Brazil or South America, you will see some superb sights, because the planets are very high in the sky. And this is one image received from the Philippines and one from Brazil recently. So there you see a fantastic amount of detail on the planet. And I think it's the combination of the chaotic detail and the grand regularities that makes Jupiter such an endlessly fascinating thing to study. So here you see a great deal of turbulence and weather going on in this belt here, but the belts always reappear in the same positions. So it's a balance between chaos and order that produces the patterns on Jupiter, and that with the constant changes they undergo still makes them regular and understandable. So this is something that we're observing and studying still in the BAA. We've got 130 years of records of what's going on Jupiter, and we still see patterns now that help to illuminate the patterns that have been seen in the past. Now, the images now are so beautiful that if we animate a couple of them, as you see here, you can see the winds on the planet. This is a pair of images from Curaçao and South Africa, taken over 20 hours. And you see here that all of the equatorial region is blowing rapidly to the right, that is to the east, whereas other latitudes, for instance, here there is a jet stream blowing to the left, that is to the west. And although this is a very quiet side of the planet, you can see a great deal of movement eastwards or westwards in most latitudes. And that's because there are these permanent jet streams, and they're the fundamental structure of the atmosphere that we can see. So this is a chart of wind speed against latitude obtained from the Cassini spacecraft, showing you where these jet streams are. Where the graph moves to the right, that is going eastward. And so there are eastward jet streams in the latitudes indicated by these lines here. And those define domains. Not a lot crosses those eastward jet streams. They're very sharp and very fast. But within each domain, there's a great deal of weather and a great deal of activity. So we name these domains aligned with the traditional belts and zones. So the South Tropical domain here encompasses the South Equatorial Belt, which is this big dark one here, and the South Tropical Zone, which is this bright white area here. And likewise for the others. You don't need to remember all these names, but just to be aware that if I refer to the domains or the belts during this talk, this is what I'm talking about. In addition to all the amateur observations, of course, we also have the Juno orbiter. It's been there for 4 years now, orbiting Jupiter every 53 days. It's not basically intended to take pictures, but it does have a camera on it, which was originally intended for public outreach. And I've been privileged with several other amateurs to be heavily involved with the JunoCam team in interpreting and predicting what's going to be seen in those images. Juno's orbit has been evolving over these 4 years. Basically, it's the same 53-day orbit, which comes very close to the planet. Here, this is Jupiter here, every 53 days, and typically flies over at a very low altitude, 3,500 kilometers. Then it goes out on its very long orbit, and it only takes images and data on Jupiter itself during the period of several hours when it's flying close by. That's called perijove, the time when it's closest to Jupiter. Now, over these years, the orbit has shifted a bit. So it was perfectly polar at the start, passing directly over the poles, and the perijove and apogee were roughly in the plane of the equator. It's shifted now so that it's not quite as polar. It's tilted by 75 degrees rather than 90 degrees. And now the perijove is more over the north temperate belt. But the images are still as good as ever. Another feature of the evolving orbit is that it crosses the planets at a different time of day on Jupiter now. So instead of looking straight down, it now tends to be looking at the horizon when it's at low latitudes. So the equatorial region nowadays looks like this, but this is what it was like at perijove 20, which was sometime early last year, I think. We see a rather oblique view. This is the whole of the equatorial region here from one side to the other, and you see all this fantastic detail in the clouds. In fact, at perijove 23, when it passed over the noontide hour on Jupiter, this was the view. For one moment, it could see all the way around the horizon on Jupiter. But now, as we come out the other side of noontide, the view is becoming rather less oblique. We're beginning to see more of the equatorial region. We still see masses of wonderful detail at high latitudes and over the poles. And so for each of these perijoves, we try to produce maps that will aid the Juno team in various ways. Sometimes we produce predictive maps to predict what will be under Juno's track at the next perijove, and whenever possible, we also produce maps, all of it was derived from amateur images, to show what was around actually on the day of Juno's flyover. This is Juno's track at the last flyover on June the 2nd. with images from these various people around the world. And this is important for the Juno team for two reasons. First of all, JunoCam itself only sees a very narrow strip of the planet when it's down at low altitudes. So if you think back to those previous images, it'd be very hard to know what you're looking at there unless you can orient it with respect to a broader map of the planet. And secondly, one of the non-imaging experiments on Jupiter, on Juno, is probing down below the clouds and needs to know whether it's passing over any particular features, such as the Great Red Spot, for instance, which Juno has now passed directly over twice, or if the belts that it's passing over, like the North Equatorial Belt, are undergoing any special upheavals or any special climatic cycles at the time. Because, as you'll see, most of these belts do undergo climatic cycles, and we've had an excellent range of them during the Juno missions so far. So for the rest of this talk, I'm going to be describing 4 aspects of the planet that are of current interest, which we can see with our own telescopes, and you'll see plenty of beautiful amateur images of them. The first 2 are really obvious large-scale events: the equatorial zone, where there's been coloration over the last year or 2, and the North Equatorial Belt, which has been drawing attention to itself with a lot of large-scale upheaval in recent months. So the equatorial zone, these images from 2018, 2019, and 2020 showing how the color has changed. And as you see, here in 2018, February, it was normal, but soon after that, an orange or ochre color began to develop insidiously. And by spring and summer 2019, it was really maximal. Now, these episodes occur at rather irregular intervals of several years, sometimes many years. The color is always sort of a yellowish or reddish color, but the intensity of the color and the darkness of the color varies a lot. In fact, this episode is the most intense and prolonged in terms of orange or ochre color that we've seen since about 1990. It's been going for just over 2 years, and it's clearly now fading. On the next slide, you see the time course in rather more detail. These are sections of cylindrical maps of the planet. So this is one from March 2018. The episode was barely starting then. It gradually intensified during spring and summer 2018. But when the planet reappeared in 2019, it was very intense, very obvious. And so it persisted through until the summer. It began to fade a bit in autumn. This is 2019 October. And when the planet reappeared this year in 2020, it was clearly fainter than it was before. In fact, at some longitudes or with some people's cameras, it doesn't look particularly impressive at all. But on the whole, it is still there. But even if the color is fading, these dark bluish features on the NEB south edge, which are always present, are looking particularly impressive at the moment, particularly large and complex. They often have these festoons draped into the equatorial region and other projections from them. And with this combination of those dark bluish festoons and whitish areas and the residual ochre color, we're seeing a really remarkable pattern of colors and streaks in the equatorial zone. Now, JunoCam, looking with about 100 times higher resolution, is seeing the pattern looking even more spectacular. These are images from Perigeo 26 in April. And this is the width of the equatorial zone here. And you see a fantastic array of colors and clouds. And looking at maximum resolution, here you see a lot of wave patterns over the color and over the clouds. You see some puffy clouds in various places. Sometimes we see rather sharp lines here and there. And here you see the shadow of one of Jupiter's tiniest innermost moons projected on the clouds. So JunoCam has actually acquired an excellent series of images of the equatorial zone while this coloration event has grown and then subsided again. So it should be good data to allow us to know a little bit more about what is happening to the clouds during these events. Moving on then to the North Equatorial Belt. This has a climatic cycle which consists of a broadening of the belt to the north. It's quite a complex cycle. We now know that there are many other features involved as well. They typically occur every 3 to 5 years. And the most recent one was in 2017. And this series of maps here illustrates what happened and typical progress of such an event. So just the previous December, the belt was a fairly normal width. But in January 2017, there were some rifts here. Now, rifts are what they look like visually, i.e. white streaks, but in fact they're convective outbreaks. They're vigorous storms pushing up clouds to high altitudes, probably on the whole thunderstorms, lanes of thunderstorms developing. And they then expand and are drawn out to great length and complexity. And as that happened, in this instance, the dark belt broadened to the north here. You can see it's broadened by a few degrees latitude and begun to envelop some of these white ovals that were present in the belt. So by the summer, it had fully broadened the belt all the way around. White ovals were enveloped, new patches or ovals were developing. And then by January 2018, a year after it had started, it was receding. The dark material was receding, but leaving some impressive features that had developed during the expansion event. So this slide summarizes what we've seen in 2020. The belt was fairly normal in February. It did have a lot of prominent projections along the north edge, but then that is common. And we didn't notice anything abnormal for a couple of months, but then in retrospect, this great upheaval had started with a couple of little white spots that were hanging around in this area in February. Well, about that time, they began to proliferate, and this rift system developed with a lot of these little bright outbreaks, convective storms developing. And this became more and more elaborate and extensive, spreading around the planet. Then by April, it began to emerge that the dark material was spreading northwards in areas that had been affected by the rifts, while the rift itself continued to propagate around the planet. And by May, there was clearly dark material happening, emerging here up to the north, and distinct bright ovals and more light grayish ovals appearing between those darkened sectors. As of June, the rifted region had gone all the way around the planet and was beginning to cover the area that had already been affected. And in fact, it appears to be causing some of those areas to fade again. So at the moment, it's not clear whether this event is going to go to completion. It probably will, they almost always do, but the disturbance is really still very intense, and there's every reason for continuing to look at the planet and see what's going on. This was it in May, early May, when we could see these anticyclonic white ovals arrowed in red here. This is one that's been around for over 20 years, but this one was fairly new, and some were actually developing at the time. And there are also these other features. These are little tiny cyclonic dark spots, and these are other more mysterious pale spots, some more complex spots in between the anticyclonic ones. Those weren't something that we really recognized from ground-based observations, but JunoCam happened to get a very nice image of one of those in February. This is a couple of those white ovals, the anticyclonic white ovals at the edge of the field of view. And in the center, you see this pale spot was in fact a beautiful regular cyclone, which are quite rare in the North Equatorial Belt. Usually it's more chaotic in these latitudes. But this was a rare example of a large and well-formed cyclone in that belt. Okay, so we carry on waiting to see what will happen to the North Equatorial Belt. Probably it will continue to broaden, and then the array of ovals and dark cyclonic features may develop as well. Let's move on then to the Great Red Spot. Now, I'm sure you all know about the Great Red Spot, and you probably also know that it's been shrinking over many, many years. These are historic photos and drawings, so they have south up. But it shows that the red spot has shrunk until it's recently less than half the length that it was back in the 1880s. In fact, 2014 was the time when it had a rather notable shrinkage. Since that time, it's stayed fairly static at about 14 degrees long. That's about 16,000 kilometers, I think, until last year. Now, last year, some surprising things started to happen. What's happened is that it appears that red flakes are being torn off the Great Red Spot. And this was first seen in JunoCam images in December. That was during solar conjunction in December 2018. 53 days later, in February 2019, JunoCam images showed very similar thing happening. One of these red strips, or as we call them, flakes, which look as if they're detaching from the Great Red Spot. By this time, amateur imagers were also able to take pictures of the planet, and we're seeing the same thing, a rather reddish one here, and again in this image. Now I show here some images in the methane band, which are particularly useful for seeing what's going on with these flakes. In the methane absorption band, in the near infrared, features that appear bright are those that are high altitude. So all we need to know for the purpose of this talk is that the Great Red Spot, its red color, is a high altitude haze or cloud layer. And so when these flakes appear also bright in the methane band, that means they're also made of similar material to the Great Red Spot, and may well have been pulled out of it. In fact, this one imaged here by Chris Goh on March 29th is, I think, the same one that was imaged by JunoCam a week later. And what you can see in both color and in the methane band is that flake that was emerging then has now become drawn out at great length and complexity as it's got tangled up in the westward flowing jet stream on the SEB south edge. But also there's a protrusion here from the preceding end of the Great Red Spot on the east side, and it looks as if this may actually be a part of the same flake that is now getting pulled around the Great Red Spot, because the Great Red Spot, it's an anticyclone that circulates around anti-clockwise. The internal rotation period is about 4 days, but on the outside edge, we found that these flakes tend to be moving around with a period of 9 to 10 days. And so that is probably why this long streak was drawn out there. What emerged after we'd observed several of these during the first part of the apparition, and the credit for this particularly to Shinji Mizumoto in Japan, who put all the data together, we found that it depended on rings on the SEB south edge that come in here on this jet stream and are drawn into the red spot hollow. Now that's a normal phenomenon. These rings are they're common on that jet stream. This is one that's been drawn in and distorted. So all that's pretty normal. But what was unusual is as they come around here, and they usually get torn apart or at least become indistinct, they would draw out this red material, this red flake from the Great Red Spot, and it would really emerge when it got to the west end, the following end of the Great Red Spot. Then sometimes we could see the flake material being squeezed through around the south side of the Great Red Spot, and also emerging at the east end of the spot. This was a particularly large one that emerged on the date of this base image here in May 2019. And sometimes these could become very elaborate. This was an image taken just a few days after that previous one, showing that flake was now very long. You see it also in the methane image. And in there you can see how the attachment to the Great Red Spot still exists and has been dragged now 360 degrees around the spot since it was first created. So what's happened since then? Well, during solar conjunction, JunoCam continued to image the red spot from time to time. And here in February, at the beginning of the apparition, you could see that there had been a flake emitted, quite a large one by the looks of it here, and something else going on at the east end. Now, since the apparition really got underway and amateur images are showing the red spot, we're really not seeing very much in the way of flakes. There have been 4, but they haven't been very impressive. What one mainly sees is the red spot surrounded by this sort of blurry brownish stuff. But this JunoCam image on June the 2nd shows that that in fact is made of lots of very narrow tendrils of red methane bright material. Again, they're most distinct in the methane image. It looks as if these are probably the remnants of flakes drawn out in weeks or even months previously that have been wrapped around the Great Red Spot perhaps several times. This is an animation of two images by Clyde Foster in South Africa back in May, showing the origin of one flake that was seen. You see, it's not a very large one, but you can see it there moving, and it's enlarged up here over the 20 hours of the animation. But the most surprising thing really has been not so much that the flakes are continuing, but the size of the Great Red Spot. Last summer, just as the largest flakes began to appear in May, actually, the size of the Great Red Spot really diminished. It reduced from its typical 14 degrees to little over 12 degrees. And it looks fairly straightforward interpretation that while strips were being pulled off the Great Red Spot, they were actually tearing the edges off it. Now, this may have been purely a superficial phenomenon. It's possible that this was just the most high altitude layer of red methane bright cloud that was being disrupted, and the underlying circulation of the Great Red Spot may have been continuing uninterrupted. We don't know that for sure, but perhaps some Hubble Space Telescope's images will be telling us. At any rate, the red spot did recover fairly quickly after May and June, because at that time, the SCB South rings ceased entering the Great Red Spot for a while, and there were no flakes for a couple of months, and it was during that time that the red spot did recover. So we know that there were more flakes going on in the autumn and during solar conjunction, and there have been a few not very impressive ones this year. However, the size of the Great Red Spot has resumed shrinking, and it's now down to a length as small as it was last summer. Now, is this the accumulated results of all those flakes that have been happening, or is it an independent renewal of the historic shrinkage? We don't know, but it's certainly something to keep an eye on and perhaps to collaborate with professional observers on. Okay, the final topic I want to cover, very fairly briefly, will be the South Temperate domain, because there's a very interesting phenomenon developing there. There is a cycle of structures that happen in the South Temperate domain, and it's rather complicated, so I'm not going to go through it in detail. But most of the time, there is only, at the moment, one prominent feature in the domain. It's oval BA, which is its only big anticyclonic oval. It's sometimes reddish, sometimes white, and the dark patch of South Temperate belts immediately following it, which is often quite small. But there are other structured sectors of the domain. There's always at least 2 or 3 of them altogether. One of them is shown here. We called it the STB ghost because it was just a very pale, ghostly feature, difficult to see except in really good quality images. But we were able to establish that it was a cyclonic circulation and a very persistent one, and it gradually expanded and it continued to propagate eastwards relative to oval BA, eventually catching up with it from the other side in early 2018. Now, while that was moving towards oval BA, leaving this long blank space, another structured sector appeared, and it appeared in the form of this little dark spot, DS5 we called it at the time. It emerged moving eastward and eventually becoming a feature indistinguishable from the STB ghost. So we called it the STB spectre, and that has recently arrived at oval BA. So with that, we certainly expected that another sector would emerge, and it was expected to emerge in those tens of degrees preceding oval BA, because that's where they normally do. Oh, incidentally, this is pictures of the STB spectre as it expanded, 3 JunoCam maps at the same scale, showing how it expanded over a year or two. This is an animation of the other one, the STB ghost, showing that it is in fact a cyclonic circulation. It's moving around in this direction. This is a blink of 2 images over just about 10 minutes, put into map forms by Gerald Eichstädt. So we've been looking for new features arriving, appearing there. JunoCam images sometimes show some vortices there, but nothing very impressive, until early this year, when the amateur images showed that there was this new dark spot there. And so that looks very much like that DS5 we saw earlier, and could well be the start of a new structured section. We could also see this very obscure little streak here with a little white spot perhaps in the middle of it, and maybe that was going to be one as well. Well, in fact, JunoCam got a superb view of most of this region on April the 10th, which was its last perigee of 26. This is a JunoCam map, and I've marked on it where you could see currents in animations of the images. It did give a very nice view of this dark spot, and we could see that here it is. It is indeed a cyclonic spot, as you can see from these streaks around it, and it looks like a pretty powerful vortex. It was in fact deflecting this jet stream around it, we could see from animations. So it's just the sort of thing that might expand to become a new structured sector. But the big surprise has been the other feature I pointed to, that extremely obscure little streak and white spot. Clyde Foster discovered this phenomenon on May 31st. It's become known as Clyde's spot. What he saw in his methane band images of that day was an extremely bright, small spot that had appeared, and it turned out it was exactly at the position of the center of that streak. It was never very impressive visually. There was a white spot there, but it's always very small. It faded very quickly in both the methane band and the visible wavelengths. But something was still there. There was still some tiny disturbance going on. In the methane band, it appeared to become double. More little spots appeared visually and sort of moved around, jostled around in that spot. And it's gradually gradually evolved into a dark spot in that region. Now, the most fortuitous thing about this was not only that Clyde actually captured it during the 24 hours that it was conspicuous, but also that 2 days later, it was imaged by Juno, which flew over that longitude and was already scheduled to image that region. This is Juno's pictures, and what you can see in the visible light image is that indeed there is a strong cyclonic vortex there, as indicated by these streaks. But the white cloud, which is what had appeared in Clyde's images, looks like it's expanding over those cyclonic streaks. And these arcs in those white clouds suggest that it is an expanding cloud, probably driven outwards by the eruption. Again, it's presumably a towering thundercloud driven upwards by convection from a deeper cloud layer that is making some kind of transformation in that spot. So what has happened to it since? Well, it has evolved into this dark spot here, which was nearly as dark as the first one, which is now passing the Great Red Spot. So either of those or both of them together could produce a new structured sector of the SCB. We have to carry on watching and waiting to see what would happen. So that brings us up to date to opposition. As you can see here, there's Clyde's spot. And in fact, you can see that this image was taken around the time of opposition by Neil in Australia, because it shows Io in front of its shadow. And that shows that it is indeed opposition, because the Earth is directly between the Sun and Io and Jupiter. So that's what's going on at the moment. Many thanks indeed to all of the observers who've produced all these images, and all the ones you haven't seen as well, and to the NASA JunoCam team who continue to produce these splendid images from the spacecraft. And thank you all for your attention.
Thank you, John, for a fascinating talk on Jupiter. To everyone who's attending on Zoom, you can write questions by typing in the Q&A, and you can actually do that at any point during the talks, and then we'll come to the questions at the end of the talk. And we'll be taking questions up until about 7:45, when Robin Scadgel will take over to give a brief talk about the comet in What's Up, and then we'll be on to Greg Smyth-Rumsby to give us a talk on myths and illusions. So I see we have a couple of questions come in. I'll also try and keep an eye out on YouTube for any questions, though it'll be easier to pick them up on Zoom. We have a question from Eddie Carpenter. You mentioned Metis in transit on one of your photos. Can Amalthea ever be seen in transit?
we only see the shadows of them because at close approach, Juno is actually below the orbits of all the moons and the rings. So what you saw there was actually the shadow of Metis, and JunoCam has seen the shadow of Amalthea twice. Yeah, just fortuitously, because the images only show what happens to be where the spacecraft is pointing at the time. But that we initially thought that was extremely lucky, but actually if you calculate it, the field of view and the fact that there are at least 2, possibly 4 of these satellites that could project shadows, it is about the expected frequency that we've now seen these shadows 3 times.
And we next have a question from James Dawson, which is, why has the Great Red Spot persisted for so long?
Well, there are lots of models of the atmosphere of Jupiter, the Great Red Spot we know is an anticyclone, and various models can produce anticyclones that do last for a very long time. The main reason is simply that there's nothing to stop it. On Earth, cyclones and anticyclones die out pretty quickly because there is friction with the surface of the Earth and with the ocean and continual turbulence going on. On Jupiter, it's all gas as far down as we can detect. And the Great Red Spot, we know from Juno, goes at least 300 kilometers down. It may go even deeper. And so there is very little friction on Jupiter to stop these circulations from persisting. Having said that, clearly it is changing. And we don't know if that is because it is gradually kind of running out of steam, or because there is some dynamical phenomenon that causes these anticyclonic features to contract, because others have also tended to contract like that. Another idea for why it continues to go, even if there is some loss of energy, is that these SEB South rings, the sort that are now coming in and causing the flakes, may have been actually putting energy into the Great Red Spot. It's not at all clear if that does happen, but it's one theory that's been advanced. Even if they were putting energy into the Great Red Spot, at the moment, one would worry that they're actually taking energy out of it by stripping off these flakes. It's something that requires a great deal of professional modeling, and also perhaps Juno's observations of what's going on under the clouds, in order to allow us to understand the Great Red Spot rather better. So those are the ideas that are predominantly going around.
We have 4 more questions and a comment from Glenn Orton, so we'll see if we get time in the next 5 minutes. Glenn Orton's comment is, Clyde's spot is also marked by generally bright 5 micron radiance compared with its surroundings, meaning that it is relatively devoid of cloudiness and therefore a region of downwelling winds.
Okay, well, thank you very much, Glenn, for that comment. Glenn is one of the leading astronomers of Jupiter in the infrared wavelengths, and so he knows absolutely whereof he speaks. And that's very interesting that it's become such a kind of hole in the clouds, which is consistent with it being a powerful vortex.
We have a question from Michael Wong. You mentioned 2 cycles, the coloration of the equatorial zone and the expansion of the NEB just after. Do these usually follow in sequence like this?
They do. They have sometimes in the past happened at about the same time. At the moment, with the NEB cycles going so frequently, it's very hard to say what is cause and what is effect. I mean, the color came on between 2 NEB cycles, in fact. And that color has more often been associated with cycles of the south equatorial belt, which isn't happening at the moment. So it's a bit hard to say what the association is. I must say in 2012, there was a rather clear association, because then there was a very dramatic expansion event of the north equatorial belt, a particularly intense one. And also just at the same time, there was a coloration event in the equatorial zone. So I personally believe there is a connection with events in either of those neighboring belts, but you don't see a visible connection. You know, the equatorial color is predominantly in the middle of the equatorial region, and we don't know of any theoretical reason why there should be a connection. So it's really something that is a topic for further research, I think.
We have a question from Mark and Ruth Radish. Fascinating talk, John, thank you. What is your prediction for the Great Red Spot over the years to come?
Ah, I mean, is it going to disappear? I suspect that the present shrinkage may last, and it may stay at 12 degrees long for a while. See, there has been a precedent for this, because the present great red spot may not have been seen before the 19th century. It's often said that it was seen by Cassini in the 1660s, but the spot that he saw was actually much smaller than what people saw in the 19th and early 20th centuries. And while our spot has been shrinking with fluctuations, but generally shrinking since the 19th century, Cassini's spot was much smaller, and it had a slower rotation period. And our red spot now seems to be moving towards the state of Cassini's spot. So I think it will get there, and perhaps only within our lifetimes, within the coming decades. Whether it will completely disappear or not, I rather doubt it, because all latitudes on Jupiter have spots of this sort, and there is a conjecture theoretically that they are required to take up the surplus energy that can't be accommodated in the jet streams. All those convective storms you see are continually releasing energy from Jupiter's interior that largely goes into the circulations, either in the jet streams or in ovals like the Great Red Spot. So I think if it wasn't there, a new one would appear fairly quickly, as has happened in the South Temperate region on a smaller scale. Oval BA is the only surviving large oval there, but previously there were 3 of them. They've merged to form Oval BA, and it looks like there always has to be some structures in the South Temperate region, perhaps to take up the energy that is generated in the turbulent regions. So I can't really hazard a guess for the lifetime of the Great Red Spot. It could yet be centuries, but I suspect it's going to carry on shrinking to a smaller stage than it has been until now.
Thank you, John. We have 1 minute to go, so I'll just shall we try to get through one more question?
Mm-hmm.
And this is from Paul Loveday. Very interesting talk, thank you. May I ask what it is that makes the colour more intense during coloration event, and do we know what the material is?
Oh, that's a very good question that decades of research have still not answered. Why it becomes more intense then is really not known. We do know one very interesting thing about those equatorial coloration events that Glenn Orton and his colleagues, particularly Arati Antoniano in Leicester, discovered a year or two ago. And that is they're often accompanied by clearing of the deeper clouds in the infrared. So deeper clouds can be sensed in the thermal infrared. And they've discovered that those clouds tend to clear at about the same time as the visible coloration appears. In fact, in some cycles, there's more of the visible coloration. In some cycles, there's more of the deep clearing. So that seems to be another aspect of the same phenomenon. Now, it may well be that some reddish chemical is coming up from below during these events. We think that's what happens with the Great Red Spot, that it's chemicals coming from below that are lofted up to high altitude and then react with chemicals in the upper atmosphere under the influence of solar ultraviolet to produce the red color. But we don't know if it's the same red color in the equatorial region. It is similar, but never becomes as strongly red as the Great Red Spot. So that's kind of what we do know about these features, but as you see, we're still hoping to find out exactly what the color is in these belts and zones.
Thank you, John, and thank you for all those answers, which were to such a fascinating topic. I'm pleased to say we have about 150 people with us tonight across both Zoom and YouTube, and with the stream to YouTube, we're also recording it, so it will be available after the event if anyone misses any part of the talk. I'll now hand over to Robin Scadgel, the Vice President of the SPA, who will give us an update on the sky in What's Up.
Hi there. Well, it would have been very odd, wouldn't it, if we hadn't mentioned the comet on this joint meeting. So that's what I'm going to do very briefly, and also draw your attention to something rather unusual which is happening in the sky in the next few days. So I'll just share my screen now. You can see, oh, it's the wrong one. Oh yeah, what's going on? Can you see my PowerPoint now?
Yes, I can see your PowerPoint.
Right, okay. Just make sure I'm...
And John, I'm just going to turn off
Yep.
your screen and mute you now.
Right.
Okay, right. Well, what's up for July 2020? And there's a picture of mine of the comet a few nights ago, and it is a fabulous sight. Now, I have to say that if you haven't seen it, the pictures which you'll see now are a bit of an exaggeration, but nevertheless, it is really obvious in the northern sky. Until a few days ago, we weren't really sure whether it would appear. As most people know, there have been a couple of real comet flops over the last few months, and nobody likes predicting comets. And so fortunately, our prediction the hopes have been fulfilled this time. So let's have a look at a few photographs. Here's one from Stuart Acton, who is the SBA Comet Section Director. He's been waiting for ages to get a picture of the comet over Kendal Castle there, and that's a lovely view. And it gives you an impression of what it looks like. Now, the close-ups of it make it look as if it is really a mammoth thing in the sky and you can't miss it. But you do have to know what you're looking for, and if you were just casually glancing around the sky, you might not notice it. And I know some people have said, oh, there is no comet, because they haven't looked close enough to the horizon, or they weren't looking at quite the right time. But once you see it, unmistakable. There's another lovely view there, taken from, I'm not sure where, but you can guess the impression from the stone circles in the foreground that it's either in Scotland or Ireland. I don't know. I've been trying to find out where Mr. Jeffers lives, but that is an absolutely beautiful sight. And I suspect there are some noctilucent clouds, those brighter clouds in there as well, which a lot of us saw a few nights ago on the 11th, 12th, a fantastic display of noctilucent cloud about 2:30 in the morning, which was really, really good and colourful, and with the twilight view of the sky and all that sort of thing. Absolutely lovely. Here's another one which shows the head of the comet, and you can see this dual tail, which it is in the dust tail, this sort of dark band down the middle, which is very, very obvious. Also, people have commented on the colour of the comet. It does have a warm yellow sort of colour, and this was commented on also by Paul Abel, who this is, knowing Paul, this has got to be a drawing, and here we are through the times 38 through a 305mm reflector on July the 11th, and just switching between the two, you can see very much that Paul has caught all those the dark band down the middle. In fact, put some detail into it there. I should have said that this is Comet C2020 F3 Neowise, in case you didn't know. There are lots of Comet Neowises. That's discovered 28 to date. There was actually a C2019 F3, so this is why we're very careful to put the actual the designation up there. Here's one from Nick James, who is the BAA Comet Section Director, and this is in a negative view. And to be honest, I don't know how he's done it. And there's another one following showing the ion tail, the gas tail from the comet, which is in a very much a more contained direction, and this was away from the sun. And this was taken not far from where I'm speaking at the moment, from Chelmsford, and he's got the tail out to 11.5 degrees. A fantastic bit of work there, and also some synchrones in the comet tail itself. And if you thought that was good, have a look at that one from Damien Peach. Now, if there are ever astro photographs taken, you can always wait for Damien to top the lot of them. And together with Ian Sharp down in Sussex, they've taken that fantastic view. Given that Chichester was to the north, I just cannot understand how they managed to get so much detail that shows how much processing has got to be done. It certainly doesn't look like that with the naked eye, but you see that and you think, wow, I've got to see it. But look carefully to find it. And you can see those synchrones in the dust tail as well, that were emitted, bands of light emitted previously over the last few days and weeks, perhaps. Where would you find the comet? Well, look to the northern sky, and it is pretty well due north. The Capella is not visible in this picture, but it's over to the right, at the top right of that, and the comet is getting higher night by night. We are roughly, well, 14th, 15th, 16th, you can see there, it's getting a little bit higher each night, but the brightness is decreasing as it is getting farther from the sun. And currently it's difficult to say the actual magnitude at the moment. Here's a graph that was taken, I just took a very short while ago, of estimates, and you can see it's roughly about magnitude 2.5. Some people are making it brighter, about 1.8 or something like that. But nevertheless, it's pretty well on track for the predictions. And just to go back, as you get up to around this point here, it will incidentally be at its closest to the Earth on the 23rd, but the magnitude then in this area here is given us about magnitude 3 or 4. So although it will still be quite evident in the northern sky, it won't be as bright. And it's a bit of a trade-off between height above the horizon and therefore slightly better viewing conditions away from the murk and so on the horizon, and distance from the Earth, so it will perhaps appear a bit longer in terms of the tail, but also decreasing distance from the sun, and therefore it will get dimmer. So don't delay, have a look as soon as you can, and look to the northern sky. And of course the moon's getting out of the sky now, so it will be much more obvious. And finally, I wanted to show this thing, which you might have to move the pictures of speakers off the edge there if you want to see the whole thing. I haven't heard this mentioned much in the press, but all planets are visible in a few days' time. Going from the left there, this is the view on the 19th, incidentally. You'll have a crescent moon there. This is from Stellarium, and it shows it as a blob rather than thin crescent. But take it from me, that's a thin crescent. And you have Mercury. Then you have Venus. Then you have Mars. And I'd like to have Jupiter and Saturn in the order out from the sun, but they don't quite play ball. Saturn and then Jupiter. And we also have Uranus and Neptune in the sky, and even the brightest of the minor planets, Ceres. And now I've been trying to find out. Oh, incidentally, also since I show you Capella, obviously off to the left-hand side of the screen, you will find a comet as well, and maybe if you're lucky, noctilucent cloud, and of course the Earth in the horizon as well. So that is a unique view of the solar system. I have been trying online to find out when that last happened. You could see all the planets, including, oh, incidentally, as John mentioned, Pluto as well, just about down there. So you've got the whole set, and that is, I'm sure it's once in a lifetime, and it only takes place over the next few days from the 15th to the 27th. You have to be up at about 3 in the morning to see it, but or 4 in the morning, but that is something to view. And I wonder if anyone will get a photograph with some wonderful instrument showing the whole lot. Okay, well, that's all I've got to say. And now I'd like to hand over to, well, I think Andrew will do the honors and hand over to Greg. We have heard a lot of talks from Greg over the years at various society meetings, and he is a wonderful speaker. I'm going to be intrigued to find out, usually when he occupies a stage on a live meeting, he really does occupy it and fills the stage and sometimes the rest of the auditorium as well. So it'll be interesting to see how he copes with a small screen. So over to Greg.
Thanks, Robin. Okay, I'm going to share my screen. Let's go and give that a go. Where are we? We cannot start screen. Well, there we go. I'll say okay. Let's give this a go. No, Robin's still there. Hang on a second. There we go. Desktop. Yes, please. Share. We all got there. I think we are there. Let's close that off. And let's go. You can all see my bits here. This is rather good, isn't it? I think I had to restart my computer, so everything is in the background, which is great. You can see Greg there, which is nice. Hang on one second. There we are. And it's there. It's there already. So you can all see this. The talk is called Myths and Illusions, and it is literally all about myths and illusions that we've been prey to, or whatever you want to call it. there's a lovely Escher drawing there. We can so easily be fooled. We are just humans. We're very, very subjective. We are not objective. It's incredibly difficult for us to be objective. And there's lots of ideas about, you know, the moon landings and aliens and lots of things like that, even the flat earth, which is good to get my blood pressure up, but I'm sure it gets all of us up in a way. Galileo, I suppose, one of the few men who did not have the human condition, which is very strange, because at the time there were lots of ideas about the moon and everything. And the first man really to study the moon with a telescope, his own homemade telescope, it didn't even have a name. It was a thing, and he used the thing to have a look at the sky. And this image here that you're looking at, especially the one on the left, which is an enlargement of other drawings that he did on his pages and his notebooks and everything, it's interesting because it's Photoshop of the time. He had to stitch together the images. His telescope was completely incapable of seeing the whole moon. It was like looking through a pea shooter, a tiny thin aperture really. And he stuck the images together, and yeah, he saw craters, he saw pits. And most of the people at the time thought the moon was a smooth sphere, but he proved them otherwise, that there were pits and you know, mountains on the moon. And lo and behold, he recorded it. And not having the human condition where he would imagine there are trees and imagine there's rivers and fields and things, it was quite a thing to go almost against the grain. And then, of course, we have the Earth here, and lovely Mercator, producing north of the top and south at the bottom. I doff my hat to John, who was showing us images the other way up, mainly because of the telescopes, of course, at the time, but mapping the world also, and areas of incognita where we did not know what exactly lay beyond and everything like that. And it was because of Mercator, but that's another illusion, because we're looking at a map of the world which is flat, on a flat page, and we know the Earth is a sphere. And to imagine we can sort of unwrap the Earth and allow it to be seen on a flat surface. And when you look at a Mercator map, you see countries are tiny near the equator compared to those towards the polar regions, which are expanded disproportionately. And I know there's been many other types of projections to try and compensate for that, equal area projections as well. So I just want to show you this really, is that nothing is never quite what it seems. And I'm sure some of you have seen this illusion before. We have a checkerboard and a blue cylinder standing on it. And all you've got to do is say, you know, square A is of a certain tone and square B is of a lighter tone, or is it? You see, we are subjective, aren't we? We are incapable of making judgments. So when the hoaxers imagined that men never did land on the moon, one of the things that they cite is that, of course, the astronauts in the shadow of the lunar lander would be in complete black. They wouldn't be seen. But of course, what they're referring to is the fact that it's a vacuum in space, but not allowing for the fact that the surface rock and dust is reflecting the dust onto the non-illuminated side. And I'm showing you a mid-tone gray there, which matches the color in the back of his leg. So you can see even in the darkest part of his suit, he's still well and truly illuminated. Another aspect of the hoax about the moon is, where are the stars? Why are we not seeing stars in the sky? I'd like to see somebody try and take a photograph of a starry night with, I'm just guessing these exposures. I'm not a fantastic astrophotographer of any kind, but let's say a 500th of a second with a fairly good ISO number. And hey, you're going to see a perfect summer's day on the moon with no stars, because a 500th second of exposure will be incapable of showing you the stars. So let's make the exposure longer so we can see the stars, and suddenly Neil Armstrong and Buzz Aldrin just become a ghostly blur on the screen. Not such a good idea, perhaps. The whole idea of the moon landings is something that gets my blood pressure up a bit, like lots of other things as well. There's the moon illusion. I saw the moon the other night. I was looking towards the horizon as it was rising, and it's big. It was huge. I could barely clasp it in my fist. The reality is the moon is about 3 millimeters across at full arm's length. Pinch it between your thumb and your index finger, and it's quite a surprise. It's quite a revelation to appreciate as to exactly how big the moon is projected onto the sky. So why does it appear large when it's near the horizon? Well, it's an interesting one. It's because we have a wireframed version of the sky. I say wireframed, it's a bit like building up one of these lovely 3D models. You build a wireframe and then you flesh it out with tones and shadows and light and all the rest of it. Well, that's what we do as humans, but we are not nocturnal. We are not nocturnal. So the sky, that's the real sky. In a way, the real sky is imaginary. It's an imaginary sky. Like the Earth, it must match the sort of circumference of the Earth, the diameter, but further out, a bigger diameter. So it's part of a sphere. It's a hemisphere. How about that? We're standing on the surface of the Earth. The sky must therefore be a hemisphere above us, onto which we project the stars, the moon, and everything else. But actually, in reality, the wireframe version of the sky we have built in the daytime for us humans is the illusional sky. It's a flattened dome. When you look up, you imagine the sky is closer when directly up than it is looking towards the horizon. Look at clouds, they're the big giveaway. A nice day like this, the sun breaking through, but gaps between the clouds. As you get towards the horizon, the clouds appear to be more lenticular, don't they? So let's see how that actually pans out. There is the moon, the same diameter on the imaginary sky, about ½ degree across. But when you project the lines back from each side of the moon back into our eyes, either directly up overhead or towards the horizon, notice the size of the moon projected as the lines pass through the illusional sky. The thicker orange lines are an illusion. They tell us that the moon is bigger towards the horizon than it is high up overhead. And there you are, stretching out your arm in front of you, with your index finger and your thumb describing 3 millimeters, and you're still pinching the moon towards the horizon as you are indeed directly overhead. Okay, the moon does sometimes get a little closer to the Earth and sometimes a little further away, but it barely makes any noticeable difference. This is all to do with us. So that's why we see the moon as we do. It's the moon illusion. So the hoaxers would have us believe that you cannot have this photograph. You cannot have it. Because somehow the people on the set in Hollywood that fooled us all into believing that the Apollo program was underway and men were kicking up the dust on the lunar surface, realized that, of course, the lander had now been removed from the set and had been forgotten to be put back. But of course, you only have to move a few feet left and right. And if you don't think that those are mountains, many tens of kilometers away, not just a few 100 meters away, many tens of kilometers into the distance, you move 20, 30 meters to the left or the right, and the little lander has completely gone out of your field of vision. So I'm afraid the hoaxers haven't got a leg to stand on, nor in this image here. Isn't that wonderful? Isn't that a wonderful image of a ring laid onto the descriptive words in a dictionary of the word love? And they're forming a beautiful heart. I just love that. And that's the problem, because the shadows that we see and take for granted will describe the surface as not being flat. They'll describe lots of things, including the buckled surface of a rock on the lunar surface. So it's not surprising that when they see the shadows, that not only are they higgledy-piggledy in all different directions, but they imagine there's 2 or 3 spotlights. Wow. Okay, here comes the prize money. Whose footprint is this? It's actually not Neil Armstrong's, it's Buzz Aldrin's. And there it is. Why is it there? Why is it recorded so perfectly in the lunar dust? That's because the lunar dust is dangerous. No, it's not wet, it's not damp, it's not like sand. It's more like flour, but it's different to flour because each and every grain of lunar dust is jiggedy-jaggedy like a fractal pattern. And every single grain knots together with the grain to its side, above it, to its left, below it. They're all jiggedy-jaggedy joining together. They can't help it. So when you leave an impression in the lunar dust, it stays there. It's not going to collapse. Okay, over millions, perhaps billions of years, micrometeoritic impacts will slowly but surely erode the dust and its little imprint. But that's why NASA is working very hard to make sure that the astronauts do not bring the dust into their living quarters if they're going to stay on the moon for several months at a time. Because that dust, being jiggity-jaggedy, will kill them. It's extraordinarily dangerous, and it'll get everywhere. So make sure you climb in through the back of your spacesuit, close the door, make sure everything is sealed up on your head-up display, disengage from your living quarters, and then walk around the lunar surface for your duty of whatever. Maybe trying to find a tin of Coca-Cola, perhaps. Here's an interesting question. You're on a diving board and you're holding a set of weighing scales. And on the weighing scales is a kilo of sugar. And then you leap into the air. At what point, assuming you can get rid of the tick, 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 of the little pointer on your weighing scales jiggling all over the place, at what point, after having left the diving board, do you see zero on the weighing scales? It's an interesting one, isn't it? Actually, you'll see zero the minute you leave the diving board. On the way up, you'll be at zero. Your body will be zero weight, because weight is a strange thing, isn't it? It's all relative. It's all to do with gravity. But gravity is controlling our fall, as indeed the moon falls towards the Earth. What you see in this diagram are not to scale, although the size of the moon and the Earth are to scale. The distance is not. The moon on average is 384,403 kilometers away from the Earth and moves at a little over a kilometer per second in orbit around the Earth. But of course it falls towards the Earth. Now the next few slides are not going to appear quite right because I'm slightly cheating. I'm showing you the moon moving forward at just over a kilometer per second. And then I'm going to put a datum on the screen. There's that faint blue line. That's the datum. So at the same time that the moon is moving forward, it's also falling towards the Earth. But it's got to miss the Earth. Otherwise it would crash into the Earth, or the Earth would crash into the moon. So what we've got to do is we've got to make the moon move forward and fall. Now you'll see where I've gone wrong, because the blue arrow should really, if you think about it, be pointing towards the center of the Earth. But I'm referring it to that datum, that little dotted faint blue line, to give you a frame of reference. So we're going to alter the datum, and we're going to put it now with the second moon, and so on and so forth. And once again, the blue arrow is not pointing in the right direction. But you're beginning to get the picture that the moon stays in orbit around the Earth simply because it is falling towards the Earth. But its forward momentum is causing it to miss all the time. The moon moves at just a little over 1 kilometer per second, but in order for the International Space Station to stay above the Earth's surface, it has to travel a little faster, 7 kilometers a second. Yes, it's a lot faster, isn't it? I love this image. This is a terrific image. The people of old, before the so-called scientists of, the 1300s, the 1400s, and all the rest of it, they had an idea. They had an idea that the moon wasn't a flat disk, that it was a sphere. How big? They also had a good idea as to perhaps how big the moon was because of the shape of the arc of the Earth's shadow cast upon it. And in this multiple exposure of a partial lunar eclipse, you can clearly see the Earth's shadow projected onto the moon. And if we assume that light from the sun is parallel, which it isn't quite, not quite to get that shadow onto the lunar surface, but it is. The moon is about a quarter the size of the Earth. Here we're showing it at about a third the size of the Earth, but you get the idea. The people of old really weren't very stupid at all. Lacked knowledge, but didn't lack intellect. I love this image. It's of Saturn. It's taken by Cassini, and you can see to the right there, you've got Saturn's globe projected onto it, the shadow of the rings. And there's a tiny little shepherd moon trapped inside one of the gaps in the rings. Although technically the rings are just stuffed full of things and they're all interacting in rather strange and queer ways, but they do interact. And what's fascinating about this picture isn't the rings or the shadow, it's the light. The light itself is being bent. How about that? By the atmosphere above the visible clouds that we can see. on Saturn's globe. I find this picture quite bizarre, quite amazing. Montaigne, oh, look at the date. Montaigne had a telescope and he was looking at Venus. Venus has got a moon. You sure it isn't internal reflections? I don't know whether anybody can also appreciate that the moon, according to his drawing, its phase seems to shift all over the place. Yeah, it was probably his very poorly made telescope, as indeed many telescopes were rather badly made, unless if you were Galileo or some such, you might have made it yourself, in which case you may have had a fairly good telescope yourself. Here's an interesting story, a really wonderful story. This is an illusion, how we think. I said at the beginning, we're very subjective. This is the wonderful drawing by Schiaparelli. You can see all the lovely lines on Mars there. That's how we see it. I've seen Mars through a Takahashi, a 4-inch, just over 100 millimeter telescope, and it looked like this. It looked like somebody had sprayed cobwebs onto its surface. But that's the problem, that the resolution was good enough to see this level of detail. But today we can go beyond this point. Percival Lowell, a very wealthy, entrepreneurial American businessman, was fascinated not so much by the sky, but by Mars and the Martians. Of course there were Martians. Of course the moon was inhabited. Martian. You know, it takes us jumps in scientific discovery to understand all of this. When you look at that image on the left, the two little squares, tiny as they are, they look almost the same. Blow them up a little bit, they become a bit fuzzier, but when you sharpen the detail, the one above is showing you lines and the one beneath is not. And then on the right, the two big squares, clearly very different. You see, it's all a question of jumping over those thresholds. You get a tiny little telescope, barely see anything. Get a bigger telescope, you see some detail. That's where these images come in. But get to a bigger telescope with an even clearer atmosphere, and everything suddenly levels out, becomes a level playing field. And of course, the minds of people's imaginations with the Boer War and the Crimea War and World War I and all the rest of it, and world conflict beginning to show. And it wasn't much, was it, that we were going to have a crash of worlds, aliens coming to steal our fish and chips. Yes, H.G. Wells. And of course, that famous transmission in New York. There were about 5 radio stations. Of course, they're all live. There's no recordings. And lots of adverts on those radios to pay for the channel to be broadcast. And the people, when an advert came up, would turn the dial, continuous turning, and then press button dials and turn the dial to go to the next station to hear whatever was going on. And there was a sort of a panic in the streets when they bumped into the Mercury Theatre's production, where Orson Welles made his name, of course. That fantastic deep voice must have scared people, seriously. Look at the date, 1938, sort of getting to world conflict again with the ructions happening in Europe, and suddenly we're going to be invaded by aliens. People hadn't read the story necessarily, but they got the idea quickly. Thomas Jefferson Jackson C. Ridiculed, but actually a fantastic astronomer. He didn't fully understand what was going on at the time. You can see the dates there. But back in the sort of middle to late 1800s, he was doing some sterling work. And he said that he could see craters on Mercury and on Mars. And people didn't think so. They didn't think you could actually see markings, but you couldn't see the definition of craters. And he was set to one side, ridiculed, in fact. So can you actually record craters on Mercury? Well, you can see the 2 Mount Wilson images on the left there, one in 1998, one in 2007 by Dantowitz. Okay, they still look like markings and not actually like craters, but nevertheless, they are of real features. Rachmaninoff showing up quite clearly. The reason why you can't see craters on planets is because they're not high or low, particularly. They're often muted. You look at craters on the moon, you can see them because they're so close to us that you can see the shadows. And also we get the phases of the moon where we don't get phases of planets. They're usually away from us, away from the sun. So the illumination is full or close to full. Mars doesn't have a huge phase difference as it orbits the sun. So we don't get raking light defining things. So to see craters on Mercury would be difficult. And on Mars, even more so. But you can see volcanoes. Try it. Clyde Foster, South Africa. John Rogers mentioned him, and he's taken some fantastic pictures in there. If you want to have a look, at Schiaparelli, there it is. That's the Sinus Iridum. No, Sinus Meridiani, I do apologize. And you can see it there in the Mars globe. It's almost in the center, just above the center of the globe, in the center, left to right, just above middle, top to bottom. That little sort of cut is the crater Schiaparelli. It's one of the largest craters on Mars, and you can see it as a blemish, but you can't see it defined by shadows and light, I'm afraid. It's simply too small, not deep enough. When we go to Mars, we're going to go to Mars. Of course, we're going to go to Mars. It's obvious. But when people get there, what they're going to fail to realize is we are human, and our eyes are designed for human levels of illumination. The Mars's daytime is 43% less bright than it is on the Earth. 43% less bright. You might not notice it. It's about, I'm in southeast England now, and I've got about the same amount of brightness here in my garden right now as it is on a bright summer's day on Mars. It's pretty much that. So I can see things, but can I see detail? I might actually need to have a torch to see detail when I'm standing on Mars. It's something to note. There's just one aspect. This is what Mars is going to be like for real. It's not, honestly, I think we have some very clean aspects in our imaginations as to what the habitation of Mars is going to look like. How are we going to be? Look at the smelly feet. Can you smell smelly feet? I think I can. Dear, oh dear. No going down the pub. No. You think the lockdown's bad? Wow, blimey. How are we going to get to Mars? How are we going to land on Mars? That's another interesting thing, because we imagine we got an illusion that we can do it on the Earth. Well, we can do it on the Earth. Mars is really difficult. Its atmosphere is there. It provides some energy release from your speed of entry. It'll steal some of that energy to slow you down a little bit, but no, not enough. And you can't use rocket engines because they take too much fuel for heavy payloads. And you are going to have a heavy payload. I mean, Curiosity was just 1 ton. There is an estimate we're going to have to take about 40 to 45 tons of spacecraft in one go to bring enough supplies, in an emergency this is, for a very short stay on Mars, should all the other deliveries fail to happen. The water canister, breaking up on the Martian surface, and the food canister burning up in the atmosphere for whatever reason. You need to have a complete unit with the humans on board landing on the Martian surface as well. You can't just rely on the landings beforehand. Maybe you can. Maybe they'll have a think about it. So the supersonic inflatable aerodynamic decelerator, SIAD. Well, it was one idea, but I think Elon Musk with his Starship is going to perhaps produce the first realistic way of getting onto the Martian surface. Is Mars going to be a problem for us? Yes, probably. You're subject, right now, you're subject to 1G, the force of gravity at the Earth's surface. It's how our blood works, how the non-return valves work in our veins, how our liver and kidneys work to keep our blood clean, how the stomach works. Everything about us is designed for 1G. For long periods of time. Oh yeah, on board the International Space Station, they're surviving. Yes, but for 6 months. We're talking about staying on Mars for years. Could a whole human lifetime of about 70, 75 years, could that be sustained? I don't know. Could a child be born on Mars? They would be Martians. They would be Martians. And what's the likelihood? Look at this. Here's an illusion, 2 galaxies, one in front of the other. Millions of light years apart. What an amazing thing, though, to see that. Wow. Plenty of illusions out there. You've just got to look for them. And then galaxies, we look at this, doesn't it, to me, it looks like one of those, you know, Catherine wheels on firework night, doesn't it? All spinning around, all at the same speed. No, actually, the inner bit moves more slowly, doesn't it? Because it's fixed. And the outer bit moves more quickly because it's fixed to the inner bit, and it must be covering a longer distance in the same amount of time. So it must be going quicker on the outside than it is on the inside. But of course, galaxies don't actually move like that. No. Yes. Wow. So we've got 3 nice bright dots there. And I know you're going to find this hard to believe, but it is true. All 3 dots, although covering a shorter distance, are all moving at exactly the same speed. Is that weird? It cannot be. It cannot be. It's one of the reasons why when scientists were looking at the galaxies and they studied the light curve by measuring spectroscopically one side of a galaxy compared to the other side, they realized the stars were not moving more slowly as they were on the outside of the galaxy compared to those huddled near the center. They found actually the galaxies, unlike planets around the sun, the ones near the center were moving, covering the same distance in the same time. They were moving at the same speed. And that's what we're seeing here. It doesn't look like it, I know, but it's true. So how can we account for this? Why are the galaxies flying apart? Why are the stars not simply going outwards? And I don't know, because perhaps there's an invisible force in there. Or maybe an invisible stuff, which has a kind of hold. So they're going to call it dark matter. It's dark matter. And this is one of the big aspects of this whole endeavor now to find dark matter. And then, of course, we're also moving into the realms of almost fantasy with dark energy. Have a look at this if you want to prove that we're very subjective. A straight line? I've got a few straight lines. Can you see a curve? Yeah, there isn't a curve here. There's not a single curve here. There's not a single curve, and yet we've got curves. We can't help it. We're humans. And I'm going to finish up here. I've deliberately kept this a little short, just in case anybody wants to ask anybody, especially about the comet, perhaps. I've left you with this smiley face because this is also an illusion of gravity. This is Einstein. Einstein predicted that light will be bent by massive objects, and there could be, not in his time, didn't have the technologies to do it. Modern day telescopes can peer into the void and they can get the light that's wrapping around foreground galactic clusters. Now, this is a weird thing. It's weirder than you might imagine. The foreground galaxies we see as they are, but the galaxies that are bent into these arcs. Now, by the way, this is almost certainly just one galaxy. You're seeing multiple images of it wrapped around the mass of this foreground, giving it the impression of 2 eyes and a nose and a smiley face. But the gravity of the foreground galactic cluster is actually acting like a magnifying glass. It's increasing the size of this bent and distorted galaxy. And students and doctors all over the place can use computers and build algorithms to unwrap the distorted galaxies and see what they used to look like. Because if you think about it, if they're magnifying the galaxies, they are probably even further away than we might imagine. And if they're further away, they're further back in time. So we're looking at a much earlier epoch in the universe's life. So guys, I'm going to end it there. And if you want questions and answers, I believe this whole thing's supposed to end at 8:30 and we've got about 4 minutes left. So I'm going to close up shop. I'm going to stop sharing my screen. However I do that, but anyway, I can't find how I do it. Oh, here we go. Let's just close that up. There we go. And go back into here. And Andrew, can you take control of this?
Yes. And thank you, Greg, for a wonderful talk. That was really very enthusiastic and lots of fascinating things there. Although I don't think I'm going to be able to unsee that image and what habitation or exploration of Mars is really going to be like.
Yeah, wow, can you imagine? Dear, oh dear, but I really can smell the socks. I really can. How do I stop sharing my screen? I don't know. There we
I've
go.
just done that for you.
Thank you very much. Thank you. There we go.
And as before, if anyone has any questions, please use the Q&A button at the bottom. I did notice we had a couple of comments from Diane on the chat. First was to Robin, just let him know that the alignment of the planets is featured in the August edition of Astronomy Now.
Is it?
And there goes Greg.
And we got the latest Astronomy Now, came out on the press today, actually. Hasn't quite reached the bookshelves yet, but it will do. There we go.
And then Diane to Greg to say thanks. And she now has a new phrase of jiggedy jaggedy.
Oh, jiggedy jaggedy. Yeah, absolutely. Fractal patterns. Yeah. I did see the comet, by the way, if anybody's interested. I got up, I got my wife out of bed. We drove in the car. It was about midnight, 1:45, and we didn't see the comet. And then we got back home. And if only I had realized earlier at 3:30 in the morning, as it's getting light, I got out of bed. I could see it outside the bedroom window. Why did we go for a drive? I don't understand. But anyway, she wasn't very happy about the drive. Did see the comet, though.
Yes, I must admit, my views of the comet have been from my bedroom window as well. It's lovely. No questions yet, but we do have Fraser McNeil Watson saying hello and a great talk.
Thank you.
I also particularly liked the when you were talking about the sky and the kind of the illusion there with the kind of flattened, because that certainly makes a lot more sense of how it appears.
It does. Just try it tomorrow, even if the sky has no clouds in it. Just try it. Just think. Does the horizon appear to be further away than straight up overhead? And it is. It's our wireframe daytime version of the sky.
And I do kind of feel like we're beings who live in about 2.5 dimensions, because we have the free movement in 2, and although there's a 3rd dimension, we don't kind of quite get it in the same way.
No, absolutely. Yeah.
We do have a question from Fraser McNeil Watson, which is, given that the very distant galactic image, and then I think something's gone wrong with his typing, around the nearer one looked very blue despite its great distance. It says, should be redshift. Sorry, I've got it now. Given that the very distant galactic image is redshifted around the nearer one, looked very blue despite its great distance.
Yeah. I get what they're saying. First of all, I don't know. I cannot remember the name of that galaxy at all. It's true, but of course, Edwin Hubble, when he was taking the studies of the galactic distances and realizing that on average, galaxies are redshifted the further they are and the faster they're moving away from us as well. That's on average. So not all galaxies are redshifted. Some of them are blue.
And then we have from Andy Pryor, if I was stood on the moon during a lunar eclipse, would I see all the Earth's sunrises and sunsets at the same time?
Can you imagine how much money people would be asking? Elon Musk, right, do you want to go to the moon, all you lovers out there? It honestly could knock up the price very easily. During a lunar eclipse, look back at the Earth. Wow. Yeah, you would see every sunrise and every sunset on the Earth at the same time. It would be magical. And another little tiny side thing here is that for every phase you see of the moon, the opposite is happening to the Earth. So when the moon is last quarter, the Earth is first quarter, as seen from the moon. And when the moon is new, the Earth is full. So I don't know whether people get that in their heads, but that is exactly what's happening. Simple, I suppose. But...
Thank you, Greg. There's no more questions, so I'll just give a brief mention of next Wednesday at 7 o'clock. We have Owen Brazel giving us a talk on observing planetary nebula.
Fantastic. He's very good.
And thank you once again to Greg, to John Rogers, and also to Robin and Alan for helping out tonight. And thank you everyone for joining us at this joint event of the BAA and the SPA. Let there be many more in the future. Thank you all.
Thank you very much. Cheers. Bye-bye, everybody.
Bye.